Hi, my name is Rafael Sutiono. This is my student ID of 4190293. Without further ado, let's get started. Alright, so we can run this to check if we have JQ and Suricata installed properly, and that's all good. And then we can run that first. And then we can run that. Oh, sorry, we need to go to downloads first. Okay, and now we're going to count each event type. We see a lot of alerts, DNS events, HTTP events, and anomalous events. So we can see that there is some suspicious activity there. And next, what we're going to do is see for the top alert signatures. So we see 70 Quackbot JA3 hits, 48 DNS anomalies for GOSI alerts, and PE-EXE download alerts. So let's investigate each one. So the first hypothesis is the Quackbot C2 hypothesis. So we're first going to show all Quackbot alerts with the timestamps, IPs, and ports. So as you can see, all the Quackbot alerts originate from the victim at this IP to a single C2 server over here. So the pattern shows an initial burst of connections followed by check-ins at roughly 5 minutes intervals. So we can say that the verdict here is we can confirm the hypothesis because the host is actively communicating with a Quackbot C2 server over HTTPS. And as for our second payload, this is the command that we're going to be running. Okay, so you see your 4 GOSI alerts here. It shows the victim connecting to two different servers. So we've got one at this server and the other one at 72.21.81.200. So they're both on port 443, and these appear about 5 minutes after the first Quackbot beacon. And that's consistent with Quackbot downloading and executing GOSI as a second payload. So we can say that this hypothesis is confirmed because GOSI was dropped by Quackbot. And then for our third hypothesis, it's the HTTP dropper chain. So first we're going to identify the exe/dll download alerts. Yep, so we hear Suricata flagged PE executable download. So it's a Windows exe served over HTTP. And then we're going to run this command for full HTTP traffic analysis to trace the download chain. Yep, there you go. So these logs here, they reveal a two-stage delivery chain. So the first stage is the victim's browser downloads a zip from batner.com, and stage 2 is about a minute later, the file called 444.png is downloaded from alphaenergyeng.com. But Suricata identified it as a, what do you call it? Suricata identified it as a PE executable, not an image. So the user agent for this download is Haskell, and it's a non-standard agent used by the malware dropper, not a browser. So we can say the verdict for hypothesis 3 is also confirmed, that it's a multi-stage dropper chain via compromised WordPress sites. And as I mentioned in hypothesis 2, you can notice the request to store.mviewprivateoffice.com in the same output. So that was GOSI's web injection technique. And for hypothesis 4, we have DNS anomalies. So let's just run this command here. Yep. As you can see, we have a partially confirmed verdict here because the anomalies are systematic and linked to the C2 activity, but they don't constitute DNS tunneling. And for the final hypothesis, we're going to count the anomaly events first. So this hypothesis is for protocol evasion. We've got 50 of them there. And then we're going to run this command. Yep, as we can see, there's excessive TCP retransmission alerts, and there's also 50 anomaly events in the log. So the verdict here is we can confirm the hypothesis 5 because the attacker is employing protocol level and application level evasion techniques. So based on these findings, I would recommend 3 response phases. That is containment, where we isolate the host at the network level and block all identified C2 IPs. And then we have eradication, where we image the host entirely. And the third is recovery, so we scan the subnet for lateral movement using the same JA3 fingerprints and C2 indicators. So in summary, the attack chain looks like this. And that's all from my video today. Thank you.